Hi everyone, thanks for taking the time to watch the video that accompanies this month's Geospatial Tip of the Month. In this video, we're going to follow up on last month's video, and we'll show you the steps to find the time and date stamp of several imaging systems, including KOMPSAT, Pleaides 1, EROS B, and Spot 6 to 7. So without further delay, let's jump in first to Pleaides 1 and Spot 6, 7, which are Airbus sensors. These sensors are unlike the other two we're going to cover in this video in that the metadata is a little bit harder to find. So we'll go through the process of finding that for the Pleiades metadata. You're going to come to a folder. It's going to have a long extension to start with. And there's going to be some subfolders you're going to have to scroll into. So we'll do that for you. This is just the differences multispectral and pan here since we have a bundle. So we'll go into the multispectral folder. And then we'll go into the lineage folder is where the metadata is going to be found. This is the actual image itself. This is where the metadata is, and you're going to look for a file that begins with strip and then has a long string of letters and numbers associated with it. So I've already opened this file to save a little bit of time, and you can find it over here. It's an XML file, so on my computer it opens in Internet Explorer. Might open in something different on your computer, but it'll look rather similar. So we're going to scroll down. It's going to be towards the top. You're going to find a section that is a little further down here. Oh, sorry, I apologize. I have already passed it. And it's right here under time configuration. So let me start at the top here again. So we're at the top. So you just go down not too far from where we started. And we go to time configuration, time range. And right here is your start and stop time associated with the entire strip. And again, it's going to be in universal transmarcator or trans UTC. So you'll have to convert these into a local time system if that's your goal. That's going to be your date, and that's going to be your timestamp right there in the start and the end. So when you're talking about Spot 6, 7, very similar folder location, very similar look to the metadata. I show you what the file itself looks like, and similarly named. One of the main differences is going to say Spot 6 instead of P1A or PB. And I've again opened the file over here. You can see that it is again now for an S6 image as opposed to a P1 image. And it's in a very similar location. It's just a little ways down the screen here to a section where, oh, sorry, I just keep passing it today apparently. And it's right here under the time configuration stamp again. So let me start again, sorry about that. We'll go down and it is right there, not too far from the top, under time configuration, time range, and then again, it's going to be the date, and then timestamp and UTC, start and end, and this is going to be of a strip again. So now that was Pleaides 1A and Spot 6, 7. Let's move on. This time we're going to take a look at EROS B. They deliver it in what's called a pass file. It's just a Word text file. We use WordPad to open it. I've already opened it over here. Again, this is going to be for an entire strip. Very easy to find, right up near the top. We have the start and the end. They even tell you it's in UTC. They have it broken out similarly with the date and start, and then UTC, hours, minutes, seconds, and then milliseconds. So that's EROS B. You're going to find this metadata file right where the imagery was stored to start with, at least. Don't know if somebody moved it around on your copy, but that's where it starts. And finally, let's take a look at KOMPSAT-3. Similarly, it's going to be in a folder with the imagery to start with, the TIFF file that you got, the data. It's going to start with a K3. It's going to be an XML document. So again, it'll open for me in Internet Explorer. I've already opened this file. It is an extremely long file. You'll see that there's information here about the collection angles. So what we can do to kind of make this a little bit easier, you see that these little minus signs, well, they can turn into plus signs pretty easily if you just press that button. It'll take a second here to think. And then what it's going to do is it's going to collapse down that entire screen once it decides it wants to actually start working again for me. It'll collapse down that entire screen so that it'll make it a little bit easier to find. You'll see that now the entire section is collapsed, and if you were to scroll down, it's much shorter. As we talked about in the article, they break out the imaging times. It's by strip, but again, they're breaking it out by different bands. As bands are slightly offset, there's a slightly different start and stop time. We're talking milliseconds or parts of milliseconds difference. So in this example, I'm going to show you the pan start and stop time. It's going to be right here. It's going to be under imaging start time and then imaging end time. A little hard to interpret in that they string everything together, but it's a very standardized stringing of information. So if you take a look at the article that I wrote, you'll see how you can interpret it. Basically, this is your year, that I just highlighted. Now it's going to be your month. It's going to be your day. It's going to be your hours in UTC. Again, they tell you here. It's going to be your minutes in UTC. And then finally your seconds. Oops. Finally your seconds, and then parts thereof, a second at the end here. If I can get it to do what I wanted to, well, that 10 there would be included. Apologies for the copying fail there. But I think that gives you a pretty good sense of what you're looking for here. So hopefully this video was informative and you learned something about finding the time and date stamp of some of the most common high and medium resolution satellite imaging systems. See you next month, everyone.